And you can check your work with mine. I'm sure you're doing fine. I'll just show you how I graph. Maybe you can pick something up. So it says graph the following, identify asymptotes, points of discontinuity, and intercepts. Because to me, you need all that info. Not only are you asked for it many times, but you need that info in order to graph properly. So I identify all my asymptotes first because that also gives me guidelines for my graphing. So I can't factor any more here, right? Nothing factorable. So I have vertical asymptote, I'm going to write over here. Vertical asymptote, x equals -4. Horizontal asymptote, y equals 1, right? X over x, the coefficients are 1 over 1, which is 1. All right, there are no holes. And let's see my intercepts. My y-intercept, that's always easy, right? My y-intercept is, yeah, if I put zeros in for x's, I'll just get 1/4. And my x-intercept, because it's in this form, I just kind of ignore the bottom. So 0 equals x plus 1, x equals -1. Okay, so I'm ready to graph. Pick my pen up. And I'm just going to say for the record, for this whole paper, 1 tick equals 1 unit. I think that's probably going to be good enough for us. If I have to change my scale, I'll make a note of it on the individual graph. Okay, 1, 2, 3, 4. There's my vertical asymptote. Dotted line, you have to show, it doesn't have to be in red pen, but it has to be a dotted line. And then at 1. Okay, and I have 2 intercepts. I'm kind of lucky. My x-intercept is -1, and my y-intercept is 1/4, which is here. All right, I'm pretty sure I know what's going on here in this graph. I have 2 points. Very rare, a function will never cross a vertical asymptote. So I know that my graph, I can see the trend, it's moving up here, right? And graphs want to mirror image the asymptote. So it wants to become its twin, right? To run right along and look exactly like the asymptote. So I know that's what's going to happen here, and it wants to do that over on this side too. So I know it's going to do, it wants to eventually curve around and then run alongside the asymptote just like its little partner without ever touching. So I'm pretty confident that's what's happening over here. Now I just have to determine over on this side, and I'm not given any info here, so I must use a test point. Right? It's got to be anything less than x equals -4, because that's my asymptote, right? So that's x equals -4. So did anyone use a test point? Did you just go with -5? X equals -5? Okay, I'm going to use, actually I'm going to test point, because I don't have much room. Test point, x equals -5. I can't use -4, because -4 would give me 0 on the bottom, right? So I have -5 plus 1 over -5 plus 4. I get a -4 over -1, so I get 4. Okay, so at -5, I get 1, 2, 3, 4. Okay, I was kind of trying to determine if my graph was running alongside it or on this, but so I know what's happening. I know from this point, my graph is going to grow towards the asymptote and try be like it. And it's going to grow towards the asymptote and be like it here. So that's what the first graph looks like. And of course, you know, when you can do it with your phone here, or if you're at home, put the graph, after you've tried it on your own, right, put the graph into Desmos and take a look at it, right? If you want.
How do I know it's going to have 2 curves? You know what I mean? If I just do one.
Well, the asymptotes give you barriers. The graph is not going to cross the asymptotes. It'll never cross this vertical asymptote. So you know it's growing here. And usually if you get wings in both sides like this, This type graph is like the traditional graph, like the set of wings, it's never gonna cross the asymptotes. The only time a graph will cross the asymptote is if you get a weird one, like one of these guys, that doesn't have vertical asymptotes. The only time you have something that will ever cross a vertical or horizontal is like one of these guys that doesn't have any verticals. Right? But if you have the graph, the traditional one that you have with sections and with pairs of wings, it's gonna stay within its fences, its boundaries.
Well, can see something like that. How we know it should have two
Yeah.
curve. Right?
Yeah. -4. Vertical asymptote x equals -4. Horizontal asymptote y equals 1. Because -4 is your non-permissible, right? Okay, let's try this one. This one I see that I can factor, right? So in order to see what's really going on, I'm going to have to factor, and I think I get -2, -3. Be careful if you're factoring, right? I know it's easy to make a real... Okay, so now I have two non-permissibles, right? But I have canceling. So I have no vertical asymptote. I have a hole at, okay, so 3, 1. Agreed? Now, how did I get the 1? I put the 3, once it's canceled, right? This is what I use, right, Abby? I put the 3 in for x, 3 minus 2 is 1, right? Yeah. Hole at 3, 1. Now, do I have a horizontal asymptote? No horizontal asymptote, right? I have more x's on the top than the bottom, so nothing. So I'm left with a linear function, right? That's what I'm going to graph. So this is the graph of x minus 2. So the y-intercept is at +2. Slope of 1, up 1 over 1, up 1 over 1, up 1 over 1. I just have to be careful. I have a hole at 3, 1. So 1, 2, 3. Why do I have a hole at 3?
I think 4. My hole is -4.
3 and
Yeah.
this
Why does this not,
one.
okay.
X intercept should be.
Oh, let's do the intercept, sorry. X-intercept, Y-intercept. Forgot about those. Okay, let's do the y-intercept. If I put a 0 in for x, right, my y-intercept is -2. And if I put a 0 in for y, my x-intercept is 2. So let's do that too. My x-intercept is 2. I don't know what am I doing here? Did the wrong way. My x-intercept is 2, my y-intercept is -2. That's better. So linear function, y-intercept of -2, up 1 over 1. That's why it wasn't working for me. I had my intercept wrong. Okay, so let's just do a hole at 3. So that's a hole. My hole looks a little shaded. Make your hole obvious, right? And now I just have to draw a line through those points. Except I don't draw a line through your hole. And there's this rational function. So we've got two types of rational functions here, right? They're both rational, they both have non-permissibles. This is your classic kind of parent graph. It's pairs of wings. This is ended up being linear with a hole. So when you have the classic pair of wings, your graph will never ever cross horizontals or verticals. You're going to stay within their fences. So there's 4 more graphs for you to work on. You still got like 15 minutes in class, so try and get these ones. Like I say, some of them are, one of them is for sure a little strange looking, right, Eileen?
Yeah.
One of them's weird.